happy Tuesday. I hope that everyone had a wonderful, wonderful break. So a couple of reminders for today. Your quiz is coming up on the 27th and the 28th. That's next Monday or Tuesday, depending on what class you're in, right? It looks a lot closer from this side of break, so please make sure that you have been studying for that. Make sure that if you have not yet done so, you upload your limiting reactant homework to MyAW right now. Like, pause the video and upload it. We also have a lab next class, right? You'll be getting your pre-lab today, but if you don't complete that, what's going to happen? You're going to be in the hall. Don't be in the hall. Okay, so couple announcements, right? Quiz. That's going to be on everything that's including molar conversions. It's going to be limiting reactant problems. It's going to be molar ratio problems. And today we are learning about percent yield. So that will also be on there. During class today, you will be doing this percent yield homework, which is pretty small. I'm going to work through the first one with you. So that only gives you 2 problems that you have to try yourself, which means the rest of class, you are given a Unit 5 extra practice worksheet. With that worksheet, what you need to do is you need to choose 10 problems on there, and you need to upload your work to those 10 problems by the end of class, okay? This is just to show me that you're using your class time well and getting some stuff done. So we're going to go ahead and get started and dive on into percent yield. Woohoo! Okay, you guys, so everyone make sure that you have a percent yield worksheet with you, right? So this is pretty easy. So all we're going to do is we're going to read this top section and look through it together. So percent yield. The percent yield is a measurement that indicates how successful a reaction has been. In the equation below, actual, look at that, there's a word. Actual, it's bolded for a reason, is the value that you actually produce from the lab. It is measured, not calculated. And theoretical is the value that you make up in theory. This is calculated and not measured. So when we say calculated, that means dimensional analysis, right? How much do we think we're going to make? So then we actually look at the equation that we're given. And it says that percent yield is our actual, so how much we actually find in the lab, not calculated, but measured, divided by our theoretical, which we do calculate, times 100%. Pretty simple, right? So let's go ahead and look at a problem, and we're going to do number 1 together. If you begin with 20.7 grams of calcium carbonate, theoretically, there's a word that should set off our brain. In theory, the reaction should produce 11.4 grams of calcium oxide. Using the balanced equation below, you could prove that by doing the dimensional analysis, right? We could go from grams to moles, moles to moles, moles to grams. When you perform this reaction in the lab, we actually produce 6.81 grams of calcium oxide. We want to figure out what is the percent yield of calcium oxide, right? So let's look at this. Percent yield. We said that's equal to our actual divided by our theoretical. We nicely color-coded these things in here. Our actual goes on top. That would be 6.81 grams of calcium oxide, right? Actual goes on top. We divide by the theoretical on the bottom, which is 11.4 grams of calcium oxide. And then we multiply by 100%. Okay, our units here, grams are gonna cancel out, right? So if we take our calculator and we do 6.81 divided by 11.4 times 100, we end up with 59.7368%. Now, we got to sig fig this bad boy, right? So let's look at our starting things. That has 3 sig figs. That has 3 sig figs. So I get 3 sig figs in my final answer. We keep 1, 2, 3. Does that 3 round that 7 up? Heck no, tech no. So our final answer should be 59.7%. Put a box around it. That's your final answer. So you're going to go through 2 more problems, right? If we look at this, it gets a little bit harder. You got to start by balancing that. And then we want to know what is our theoretical yield of CO2 in grams if we start with this many grams of C6H6O3, right? So you're going to go ahead and we're going to go from grams to moles, moles to moles, moles to grams, right? And then you just calculated your theoretical. They tell you how many you actually produce, and you can use that to calculate your percent yield, right? So it breaks it up into 2 steps for you, and then you're going to continue to do the same type of thing for number 3. All the answers are at the bottom of this worksheet. So if I will be in class next time. I will be back from Columbia. But if I come in and we have no work written out, those answers aren't going to cut it, right? So please, please, please make sure that you show all of your work. Well, it's good practice. The other thing that you will be doing, right, is we also have that Unit 5 extra practice worksheet, right? This has tons and tons of extra practice problems on it. Look, there's so many. All the answers are also on there. I would like you to do some of this work in class today. This is extra review for your for your quiz next week, right? So you need to pick some questions, right? Pick a couple from each section, and you need to do those questions and upload them to my ADub as your in-class work for the day. Sound good? Okay, I will see you guys next class. I'm so excited to be back and be with you again. Please look on the portal if you have questions or if you're stuck. There's so many extra resources and extra videos posted on there, and feel free to rewatch this if you have any questions. Okay, I'll see you guys soon. Bye!